Hi class, this is chapter 2.3. We're looking at density, relating mass to volume. So relating mass to volume, we are dealing with mass. So we tend to, in mass, it's going to be grams usually, or unless you have to convert to grams. And volume, which is, mils, or we can use as a solid centimeters cubed. So density, what is density? Density is a ratio of an object's mass and its volume. So simply stated, how dense something is. So styrofoam is a low density material. Even though you can have huge styrofoam containers, they don't weigh very much. I don't know, places don't tend to use styrofoam as much, but when I was in high school, I worked at a burger stand and that's all we used. And I would have to move these huge amounts of styrofoam and it was just like empty space. They're very light to move, and I can move a lot of them even though it was big. Compare it to a brick. A brick is very dense. This is because the molecules which make up that rock have more mass, so think of heavier, and they are packed more close together. So think of shoving a whole bunch of people in an elevator with no room. Whereas styrofoam, it's an elevator, the mass is very light, so think of people that don't weigh very much, and there's very few in there. That's the difference between something that's dense and something that's not dense. Even if they're the same size, one you can feel is very light and one is not. And that has to do with how many the molecules are think of shoved together and how heavy those molecules are. What makes them, makes up the mass of that. So here are two items. They are the same size, but they don't have the same mass. Because the closer the atoms or molecules are closely packed together, that's going to have a greater mass. So we can have the same size of a brick and the same size as a styrofoam. But when you look in how the molecules, this one has a lot of air that can go through it. It's very low density. Think of this as an elevator. One is very sparse and the other one's very packed. So even if these are the same volume, one's going to be, think of heavier or denser, because of what it consists of. The molecules are going to have a greater mass to it because you can shove more in there, and the mass itself is probably going to be more. So styrofoam is probably made up of, I don't actually know, but let's say of something that is very light. If I put it on a balance, it's not going to weigh very much. But a brick is going to be heavier because what makes it up has greater mass to it. I hope I'm explaining that right and not just repeating myself in sentences. Okay, so density, the formula is mass over volume. Now, as we start doing this, you can solve for volume by rearranging this. You can solve for mass by rearranging this. So make sure that when you're learning density, it's not just about density. It's about mass and volume. Here is something that I want students to understand. Use the units. Your units will help you understand density. People have a problem with density. Density is grams over mils. So if you need to solve for mass, you've got to solve for grams. If you need to solve for volume, you either need to solve for centimeters cubed or mils. Density, a unit in density will give you 2 units to it. It will be grams over mils. This will help you solve for the one that's missing. Okay, so density can determine whether an object will float. If an object is less dense than the liquid, it will float. If it is more dense, it will sink. Okay, so a ping pong ball will float on water. It is less dense than water. A cylinder of iron will sink. It's denser than water. If you put values to these items, it makes it clear to understand what's happening. So a cork is 0. Remember I told you density is 2 units. Use the units. The units will help you solve problems with density. Is 0.26 grams per mils, and it's going to get heavier as we go down. So lead will sink. It's 11.3 grams per mil. Why will it sink? Because water has a density of 1.00 grams per mil. Anything heavier than that, denser than that, will sink. Anything lighter than that will float. Water is still ice. Ice is still water. How did I say that right? However, it's a different structure. And because it's a different structure, it's less dense. So you see where it floats in water because its value is just slightly less than 1. And that's what allows it to float. So if you see something float on water, it is less dense. If it sinks, it's denser. And if it stays in the middle, then it's somewhere around 1.00. That's why oil sits on top of water. That's why when there's oil spills in water, the oil will sit on top, which is very dangerous. It's dangerous. It shouldn't be in the water at all, but it's very dangerous. It will sit on top of the water. Density. Calculate the density of a substance. Use the density to calculate the mass or volume of a substance. So this is where I'm talking about you can change it around and solve for what you need. Density, the formula is mass, grams over mils. So you see, but if I wanted mass, I change mass. Mass will give me grams. I have density times volume. The mils will cancel out and it will give me my grams. If I want volume, it's mass over density. The grams will cancel out and it will give me mils. So density, if it's solids, it tends to be in grams per centimeters cubed. If it's liquids, it's grams per milliliter. Mass is in grams. Solids, centimeters cubed. Liquids, milliliters. And things can be used interchangeably. So 1 mil equals 1 centimeter cubed. You should know these things. They can change. You can, here is an example. You can change them over. Okay, a saltwater solution has a mass of 11.29 grams and a volume of 2.4 mils. What is the density? Look at the units. The units itself will also help you. Not always, but in most cases. So set up D equals M over V. Know what the mass is, which is 11.29 grams. The volume is 10.4. We are using multiplication division rules. Mass is 4 sig figs, volume is 3 sig figs, but our answer will be in 3 sig figs because of this dominating. So our answer is 1.09 grams per mil. So if you were to stick this object in water, it would not sink to the bottom, but it wouldn't stay at the top either. So it would be closer to the water, which is 1.00 grams per mil. An antifreeze mixture has a density of 1.06 grams per mil. If you measure out 600 grams of this, what is the volume? This is where you can start interchanging and solving for the one unit that you need. So here we want to start with our formula, but we're going to isolate volume, which is what we want. So mass is 600 grams. Density is 1.06. The grams will cancel out because this should flip. If you can visually determine this flipping, mils will come up, grams will stay on the bottom. Now, it's 566. So what does that mean? We have 4 sig figs. We have 3 sig figs. This is going to be 3 sig figs. And if you look here, I tried to draw this out so you can see what I was saying. And aluminum has a density of 2.70 grams per centimeters cubed. What is the mass of a block of aluminum with a volume of 1.32 liters? Okay, so let's break this down. Rearrange the formula to solve for mass. So we want mass. So here we rearrange it. Now we need to convert liters to centimeters cubed. So 1 centimeters cubed equals 1 mil. 1,000 centimeters cubed equals 1 liter. I don't like to use centimeters, but the book likes you to. I'm more comfortable just using mils and then interchanging them out. But so what I would do is I would just I know that this works. So I would just instantly use mils, and I know 1,000 mils equals 1 liter, and that's what I would put here. But that's not how your book wants you to do it. So 1.32 liters times 1,000 centimeters cubed equals 1 liters, which it does. It's just I'm more comfortable using milliliters, equals 1,320 centimeters cubed. 3 sig figs, exact 3 sig figs. There's no decimal point, so this 0 is ambiguous. So now, what did we solve for? We solved for the volume. Now we need to solve for the actual mass. So we take the density, which is given to us, and again, I would just change this to mils, but we can cancel these out, and this gives us 3,560, which is still 3 sig figs. This is 3 sig figs, this is 3 sig figs, this is 3 sig figs, there's no decimal point. So our mass is 3,560. So here's some density of common metals. You can see where water is and everything else, materials, sorry, not metals. You can see that titanium is very heavy, iron's is heavier, and lead is pretty heavy, and gold is way heavier than everything else on here. So this just gives you an idea of the density of objects. So will it sink or float? So here we have a cube of 0.4 grams per mil, and we have another one of 2.7 grams per mil. The water is 1.0. So will this float or will it sink? So, well, I'll tell you right now, if it's below 1.0, it will sink, and how far it will sink depends on how the number is. If it's close to 1, it may not reach the bottom. If it's less than 1, then the object will float, like a ping pong ball. This is very small, so it'll probably float on top. You have to relate the value numbers to what the substance it's holding in. And the closer it is to that substance, for instance, water, it will sink, it will float, or else it'll stay in the substance itself. A rectangular object measures 3.0 centimeters times 2.0 centimeters times 1.0 centimeters and has a mass of 7.2 grams. What is the density of this object? Will it float in water? Okay, so the first thing we need to do is get the volume. So this is a perfect example of how you have to solve something else before you can do the density, just like this problem. We had to do something else before we could solve the density. This is very normal for density problems. So 3 measurements, that is a cube. So centimeters cubed. This gives us the length times width times height. You make sure you multiply the units as well. So this gives us 6.0 centimeters cubed. We have our volume. Now we have our mass, which is 7.2 grams. We put one on top of the other, mass over volume. 2 sig figs, 2 sig figs. Our density is 1.2 grams. So it's 1.2 grams and water is 1.0 grams. Will it float? It will not float. It is denser. So if it was close to 1.0, it will probably stay in the middle. But because it's 1.2, it will sink. It will go down.